Genetics is often in the news, so it's useful to know how to deal with interviews on television cameras. The next section addresses this problem and shows you how you might do it and how you shouldn't do it. There's been a lot of debate in recent months about the use of human embryos for research. We're here in Newcastle upon Tyne University to talk to Dr. John Byrne about their work in the discovery of cells which can be used to treat a whole variety of diseases which have been taken from human embryos. What exactly has been discovered? What the team in Newcastle have succeeded in doing is managing to grow embryonic stem cells. Now, these are the cells from the very earliest stage of development which are capable of turning into any different tissue, liver, heart or kidney. And having those cells in the laboratory means we can start to tease apart how the genes control the early steps of development to hopefully in the future be able to develop treatments for a lot of chronic diseases. So how do you know that these cells really are stem cells? It's difficult to prove that stem cells really are stem cells, and in fact the line that's being grown in Newcastle is the only one in the UK where that's been established. The only way you can do it for certain is to inject the cells under the skin of a mouse that has no immune system. Now, that strain of mice is held by some research laboratories around the country. It doesn't hurt the mouse, but obviously it has to be killed at the end of the experiment. And looking under the microscope at those small tumours, you can see that these cells have grown into what's called a teratoma. They can be heart cells, kidney cells, liver cells, all jumbled together. But that means they've got the absolute capacity to turn into every type of tissue. What will these cells be used for? None of the stem cells so far produced in the world can be used to treat anyone because they've all been developed using mouse cells to support them. And you can't put into a human being a living tissue which contains a mixture of animal tissues. In the future, we'll develop ways of growing these cells without mouse cells, and then they can be used to treat a whole range of diseases. We already use stem cells, of course, in the form of cord blood samples to treat bone marrow failure in babies. And the hope is, and the expectation is, that these cells will be used to repair damaged spinal cords from road traffic accidents, to replace the dead cells in someone with diabetes to allow them to make insulin, and to repair someone who's got cirrhosis to give them new liver cells. So a whole range of potential treatments in the future. Do you think there are any ethical problems with the work that you're doing here? There's been a great deal of debate about the ethical challenge of this type of work. The fact is that the very early embryos from the fertility program, which were used to develop these cells, had already been set aside and were not going to be used to make someone pregnant. So basically taking those cells was very like taking a transplant donation from someone who'd been killed in an accident. What we've done is grown out cells that will take us towards being able to treat people in the future. So we think ethically it's an entirely defensible thing to do. And of course the British government have ruled that this is permissible under the Human Fertilisation and Embryology Authority's guidance. In fact, the only real ethical debate in the UK is likely to be the fact that we have to use mice in the research programme to prove that they are stem cells, but unfortunately there's no way around that at the moment. This is Erwin Thompson for the Channel 16 News. There's been a lot of debate in recent months about the use of human embryos for research. We're here in Newcastle upon Tyne University to talk to Dr. John Byrne about their work in the discovery of cells which can be used to treat a whole variety of diseases which have been taken from human embryos. What exactly has been discovered? Well, what we've succeeded in doing is culturing under standard laboratory conditions a pool of embryonic pluripotent or indeed possibly totipotent stem cells from an unwanted blastocyst at the 8-day stage, which is actually quite important because that's post-gastrulation and therefore at a relatively late stage compared to the level at which other people have done this. And how do you know that they are stem cells? Well, we know the stem cells because we've actually used a whole series of classical surface markers, the TRA160, that's the tumour rejection antigen 160, which we know is specific to pluripotent cells, and the SSEA4, which has also been identified as a very useful surface marker of pluripotent or indeed possibly totipotent cells. What exactly are you going to use these cells for? Well, I'm not exactly sure what we'll be using the cells for yet. I mean, there is a plan to create a stem cell bank in Cambridge, and we'll be donating our cells to that, of course. And we have lots of plans to examine the differentiation pathways because it's very important to understand the transcription factors which initiate the development of different tissue types from these stem cells. And we hope that that research will lead to some very fruitful consequences in terms of a whole range of therapeutic possibilities. Do you think there are any ethical problems with the work you're doing here, Dr. Byrne? Well, obviously, any research of this kind does just generate a whole variety of ethical problems in the mind of some. I mean, I have to say that we feel that it is ethically acceptable to work with these cells and that there is great potential benefit, but of course one is not an ethicist and therefore one cannot state unequivocally that this is not a source of some problems, but we feel very happy with the work that we're doing. This is Erwin Thompson for the Channel 16 News.